I get the left leg once I've got the right leg. Do the opposite. Yeah, mirror it, don't I? Right? So I've got this. Here's the fold in the paper. I'm just going to take this leg and fold it over that way. The way of thinking about that is, instead of going down 1 and right by 3, to get the mirror image point, I'd go down 1 and left way. You get right there, right? So there's the left leg. Left leg and feet. Okay? Make sense? So our answer this time is that guy. And check it, and we got it. Okay? Okay, now you also have to do the opposite. You have to start with a graph. So let's look at one of those. I think this is easier. All right, so this. You want to see what I have to do for every one of these dang questions I write for you guys? This is an easy one, honestly. But this is the coding that I have to do for every one of these stupid questions. That's the text. And, oops, hang on. Just so you can get appreciation for this. This isn't very fun. Every single one of these stupid questions involves all that stuff. And not very funny. I do. For every one of those questions, I have to write all that stuff. But that's how important I think it is to have those available to get feedback. I mean, I think that's what it takes to learn this stuff, is to be able to get feedback right away. And I write it in such a way that all the important stuff, I'm really careful, so all the important stuff that you need to know for that kind of a thing is included in those questions. And so it's worth it to me to do in a way, because I feel like it does the job for you. But it's not very fun, I will tell you. Okay, so now what about one like this? What if we do the opposite? So let's say something like that. Let's write the function based on that graph. So what's our strategy going to be? What do we have to do here, do you think? We have to look at the graph, and what numbers do we have to extract from that graph? A, H, and K, right? A, H, and K. So but it's easy, right? From the graph, what's the value of H? It's 1, isn't it? H is 1 because the vertex has been scooted to the right by 1. Agreed?
But it's positive 1.
Okay, you're right. But then when we plug it into our template, our template looks like this. Remember, it looks like A times the absolute value of X minus H, right? So that's where we're going to get the minus 1. H itself is positive 1, though, right? Okay, so H is 1. What's K? Negative 3. Okay, what's A? How are we going to find A? Say it again. It looks like 2, doesn't it? Because of that, but it'd be negative, right? Except notice what I've done here is I've actually given you 2 points that are right on the corners of the graph. So I can take those 2 points, and I'm just gonna calculate the slope of the right leg using those points, right? So I'm gonna go down, how far? 1, 2, 3, 4, 5, 6, 7. So -7, and I'm gonna run by 1, 2, 3, 4. So what's that slope? -7/4. Yeah, so A is -7/4. So then all I've got to do is input that. Have you guys used this fancy little thing? Right here?
I scribbled on it, yeah.
Okay, for some reason it doesn't work as well up here as it does like on a tablet, but try it out. Especially if you have a tablet. Here's what it does. Like if I use this, I can draw on here now, and if I want to write, so what's my function going to look like if I plug all that stuff in? So -7/4, absolute value of x minus h, so x minus 1, minus 3. Okay, so I should be able to write all that stuff here. So I get -7/4, absolute value, x minus 1. Let's see if it's doing the right thing here. So far, so good.
Whoa.
Minus 3. For some reason, whenever you put something after the absolute value bars, it wants to turn those absolute value bars into 1s. So, you can mess with it. It works pretty well. This is the first time I've seen it not work very well with absolute value bars. But it's kind of handy. It's a quick way to do algebra stuff. We don't need it, though. We actually don't need it. So I'm going to clear this out. And then to get out of that thing, I just click this little button down here, and it takes me back to the regular algebra editor, which is fine. So, oops. Oh, no. How come? Oh, let me do this. Okay, so I want to enter. Here's the function I want to enter, right? So how am I going to do this? Let's just get a little practice using this algebra editor. So I'm going to do minus fraction template 7/4. Just hit the right arrow. This is way easier to use than the HRW one, I think. You can do it all in one sitting. You don't have to go from box to box. Absolute value bars. Where am I going to get those? Now look along the top here. These are all the templates I can use, the algebra templates. Notice that whenever there's a little triangle at the bottom, like a little arrow, if I click on that, it pulls open a pop-up or like a drop-down menu with other options. If I go to the one here with parentheses, now think about your talks about, can I get everybody, phones away please? Thanks. Parentheses are just grouping symbols, right? There are other grouping symbols though. I could have brackets, I could have script brackets. Absolute value bars are grouping symbols. So this is the logical one to use, and you'll get used to these real quick. If I hit that symbol right there, look what I get, all these options. Well, there's one right there for absolute value bars. So if I click that, it opens up absolute value bars, and then it puts an edit box inside, so I can put stuff inside them, right? What goes inside, it looks like it's x minus 1. Now how do I get out of the absolute value bars? Arrow, right arrow, scoots me over, and then I'm just going to do minus 3. Make sense? Okay, check. We're good. Okay. What was that? Awesome. All right, how about that? Okay. Okay, so what I want to look at today then is just an extension of what we talked about yesterday. I want to show you a really good trick. We're going to use this trick for absolute value functions, but you can use it for anything. The way I structure this class, I've got two goals for you guys throughout the year, math goals. One of them is to get good at algebra. The algebra is the bedrock of everything you do. I would say that in my AP Calculus class, I want to say that probably 80% of what we do is algebra. And it's harder algebra, but it's algebra. You learn a lot of algebra here, but I would say that those students probably even learn more in calculus algebra than you do in this class, even though it's not technically an algebra class, because it's so much algebra. When you go to college, it's even more so. I mean, algebra just stays with you. Being good at algebra makes the rest of math simple, okay? So that's one goal. For that purpose, the way I'm going to assess you on that is I'm going to give you some tests where you cannot use a graphing calculator, you just have to do algebra. Stuff like this, you wouldn't need, like the stuff we just did, you don't really need a graphing calculator, right? But then there's another part of this too. My background is actually in physics. It's not in, I mean, I did a ton of math and physics, but really, I was not a pure math major, I was a physics major. And so in physics, you're using math to answer other questions, kinds of questions. And so the way I always approached it, a lot of math, but typically the math was a part of a bigger question. I was trying to figure out where this projectile is going to land if I launch it, and that kind of stuff, right? And so naturally, when you're just using math as a tool, a lot of times you're more interested in getting an answer, and so a graphing calculator is a great tool to get a mathematical answer quickly within a larger picture. Most of you are not going to be math majors. Most of you are probably going to use math in some other capacity to supplement something else, right? And so I want you to be used to how to use mathematical tools. Be really good at that. Use mathematical tools to answer mathematical questions. I'll repeat this later, but I can tell you right now, I know this is an absolute fact. If you're going to go into any field, but you have ability with math, that gives you a huge leg up. Even if you're a business administration major, if you know how to use math effectively, you're the one that's going to get the scholarship, you're the one that's going to get the good internship in college that's going to set you up to have a great job later. You're the one that's going to, when you're interviewed, you're the one that's going to get the job. Because not very many people know how to use math well. So if you can do this stuff, it really separates you from the other candidates. So even if math is not your strength, and it may not be, you want to make it kind of an ability that you can take with you later on in life, because people will value that, I promise you. People are scared of that. They don't want to do it. They want to hire people that can do it for them. You make that you. All right. They shouldn't be scared of that, but they are. All right, so let's look at an example here. Let's look at how we can solve an equation using technology to just get an answer. What if we had something like this? What if we had, let's say, we have the equation, how about -2 absolute value x minus 1 plus 3 equals 1. Okay, we want to solve that. Think about it this way. If I ever have an equation where I've got an expression involving a variable, usually x, on one side and a number on the other side, I can break this into pieces. I can think about the left side as just being some function. Let's call it f of x. Okay? The right side is just some number. Okay? What if I were to graph this function? What would it look like? What's the value of a, h, and k? What's a? -2. H is 1. K is, what's k? 3. So I'm going to go over 1, up 3, and the function's going to open down, and the slope of the right leg is going to be down 2 over 1, right? Well, our calculator does that pretty quickly. So if you don't have a calculator with you, come up and get one. Once again, I would strongly encourage you to go get one of these things. You can kind of get an appreciation for how much we're probably going to use it here. You're starting to. It's like an everyday kind of a thing in this class. Here's one that works. There you go. There's another one. It's a good one right there. Good one right there. You got yeah, I do. Take your pick. That one? All right. Okay, so here's our strategy. Here's what we do. We're going to take the function on the left side of the graph, and we're just going to graph it. Okay? So let's take f of x, and let's just put that into our calculator. So we go to y equals, that's where we graph stuff, right? And I want to put in -2. Remember, I have to use the negative sign there, not a minus sign. -2 times the absolute value of x minus 1. Well, how do I get the absolute value sign on my calculator? Really simple. There's 3 easy ways. If you have a TI-84 and you have the new operating system, you can use the shortcuts. If I go alpha F2, that takes me to the function template. Okay. Notice when I hit alpha in any button, it tells me there's F1 is the fraction template, F2 is function, X3 is matrix, F4 is y variable. Okay. So we want the function one. Look what the first option is. ABS. That's the calculator's name for absolute value. On the right, it tells you what it's even going to look like when I push it. So that's probably the preferred way to do it. Would be just go alpha, F2, and then either hit 1 or hit enter. Okay, another way to do it, if you don't have the new operating system or you have an older calculator or something, you could also just go math, hit the math button, and then it gives me 5 menus at the top. I'm going to scoot over to the number one. So if I hit math, then scoot over to number, it's the first option. Okay, or maybe even the easiest way is to just go second, and then if I go down here to 0, this is a catalog of variables, which normally is a really awkward way to find something, but absolute value happens to be the first entry on the numerical list. So that's another way to get there. Any of those 3 are fine. Either way I do it, I'm going to get that though, right? It's going to look like -2, and it opens up absolute value bars. And so I'll just put the x minus 1 in the middle. How do I get out of the absolute value bars? Hit the right arrow, and then I add 3. And then let's go zoom 6. And there it is, right? That's just what you told me. We scooted over 1, up 3, and we go down 2 and over 1 to get the right leg. Everybody agree with that? Okay. So then, what if we want to, how are we going to use that? Well, look at the right side. The right side of our function here is really just saying, when is f of x, which is our function, equal to 1? So f of x represents an x or a y value. Y, right? So really all I want to know is, when is the y value of this function equal to 1, right? The easy way to do that on a calculator is just to graph the line. Let's graph the line. What did it just do? Y equals 1, right? What's that going to look like? If I graph the line y equals 1, what's it going to look like? Horizontal line with a y-intercept of 1, right? So let's graph that. So go back to y equals, scoot down to the next y, so y2, and we'll graph the function y equals 1. Just hit graph. Now look what it does. Okay? Gives me this graph. It's kind of a little bit inconvenient that the scale is so small. So maybe I want to zoom in a little bit. How could I do that? I could go to the window and control it, but there's kind of a cool feature here. If I go, I'm going to put my cursor right there. Actually, hang on. I'm going to go zoom in, zoom to, and then I'm just going to put the cursor kind of over in the middle of where I want it to zoom in, like that, and hit enter, and look what it does. Okay, zooms in. That's convenient, right? So now what am I really trying to do here? If I want to find the solutions of this, I want to know, when does this function have a y value of 1? So what does that look like on my graph? What do you think? The blue function, there it is. I graphed the blue function. I want to know when that y value equals 1. So where on this graph am I going to find what I'm looking for? Any ideas? What do you think? How do we think? Any ideas? If I want to find the x values, what I'm really looking for, I'm solving for x. I want the x values where this function has a y value of 1. Where do you think that's going to happen? The blue function is the left side, the red function is the right side. Where they intersect, exactly, right? I just want to find the intersections of the left side and the right side of that equation where those graphs intersect, right? So all I have to do then, let me make this bigger so you can see it better. So yeah, and the calculator will tell us, I want to show you how to ask the calculator in case it's not a convenient answer. So all we have to do then is we're going to go, once I've got my graph up here, I go second, calc, and it gives me a menu of all the things I can calculate from my graph. Which one do I want? Intersect. So I'm going to choose option 5, just hit 5. And now look what it does. It's going to ask me some questions. What it's saying here is, what is the first curve that you want to intersect? Because what if I had like 7 things graphed on there? What if it was really complicated and I had 7 things graphed and I want to pick 2 specific ones to intersect? It wants to know, is the first curve y1? It even puts the cursor on the blue curve. Is that one of the ones I want to use? Yeah, I only got 2. How do I tell the calculator yes? Enter. Okay. Is this the second one, y2? The one that the cursor's on? Yes, it is, so I hit enter. Okay, now it asks me for a guess. Why would it do this? Calculator's pretty smart. There's a reason it asked me this. How many solutions are there going to be? You can see how many there are going to be. Bailey, how many intersections are there going to be of the red and the blue? 2. Okay, well, I got to find them one at a time, so I want to be able to control which intersection I'm finding, and so that's why it wants a guess. So I'm just going to use the left and right arrows to move the cursor over close to one of the 2 intersections so the calculator will know where to look, right? So then I'll go over to that one and I'll hit enter, and look what it tells me. The answer is at 0, x equals 0, y equals 1. So was I looking for the x value or the y value in my original equation? I was solving that equation for x, wasn't I, right? Does that make sense? And so what's one of my solutions? 0. Okay, so one thing I know right away now, that one answer is at x equals 0. Or you got to go find the other one. So I'm going to go back and do the same thing. Right? So you try that on your own. See if you can go find the other one. I'll go through it up here, and you can kind of watch me if you need to see if you can find it on your own. Second. Calc. 5. Enter, enter. Oh, by the way, that tracing can take a long time. What's the x value where I want that cursor to probably go to make a good guess? Looks like it's 2. I can just type, if I want to skip the tracing, I can just type in a 2 and hit enter, and it puts it there. And it tells me, that was my guess, it tells me what the actual intersection was, right? So if I were to have gone, that might have been confusing. So if I went second, calc, 5, and I hit enter, enter, and for my guess, what if I said 1.9 and hit enter? Then it still tells me the same intersection, right? Because my guess was close to that one. So my other solution is x equals 2, right? Everybody see that? Okay. So I found them both. Or x equals 2, right? Okay, so what would have been, based on the graph, how could I have changed my original equation so I didn't get 2 answers? How could I change it so I get 0 answers? What do you think? There's my graph. What value could I maybe have changed the right side of my equation to so I would have had 0 answers? Remember that on my graph, my solutions were the intersections of the left side and the right side of the equation. So what value could I have given the y value of that red line so they wouldn't have intersected? Like 3? Okay. Yeah. What if I said 3? So let's go back and do y equals, and let's change y2 to a 3, and I'm going to hit zoom 6 to reset the window. And, oops, I didn't want 3, did I? How about 4 or 5? Everybody agree there are no intersections? So that means no solutions, right? Could I have picked a value of y that would have made exactly one solution instead of 2? What would that have been? 3, yeah. What if the vertical line passed right through the vertex? Then it only hits it in one place, right? Does that make sense? Okay, so we can do this stuff graphically. I picked an absolute value function, but it'll work for anything. Work for the most complicated function in the world on the SAT test. If you just graph the left side and graph the number on the right side, you can use your calculator to find those intersections, right? Always works. Okay, so now, what about doing this without a graphing calculator, though? How could we do that? It's really simple, right? Let's just think about what an absolute value function actually does. Oops. There we go. Okay, if I write something like, for example, let's just say the absolute value of x equals 5. What are the values that x could have? What's one value I could plug in for x to make that statement true? 5, right? That would work. I could say one thing that would work is if I let x equal 5, that would work. Is there another one? 2 plus 3, okay, that would still be 5. Is there another value I could plug in for x that would still give me an output of 5? Negative 5, right? Because the absolute value is going to make it positive. Everybody agree? So I could also say x equals negative 5, and that would work. Okay? So what could I do then if I had something that looked a little more complicated? What if I had something like, let's say, the absolute value of x, plus 3 equals 4. Okay? It's the same idea, right? The absolute value bars are going to make whatever I put in there positive, correct? So let's not even worry for a second about what's in there. Just in general, the absolute value of hand, regardless of how complicated that expression is, what are the two things that what's behind my hand could equal? Whatever's behind my hand could equal 4, and the output would be 4, or it could be negative 4, right? Everybody agree? So then I could say right away, I could say there's two possibilities. Either whatever's in there, call a hand, equals 4, or whatever's in there, call it hand, equals negative 4. Now what do I do? Solve for x. Solve them both, right? What did we do? We traded a complicated absolute value equation for two regular simple equations that we know how to deal with. Do you see that? So that's a strategy that we've got. Whenever we get the absolute value of some expression is equal to a number, all we're going to do is just trade whatever's inside. We're going to trade for two equations. The argument of the absolute value, meaning whatever's inside it, is equal to positive c or it's equal to negative c, whatever number c is. See what I'm saying? Okay? So we could go one step further than that. What if we go to a situation where it doesn't look exactly like that to begin with? Say we want to do something like the absolute value, let's do 2 times the absolute value of x minus 1 plus 3 equals 13. How am I going to solve that guy? If I could get it to look like that, I could do it, right? But what do I have to do to make that equation have that look? What's unique about this up here? How's that different if I have the absolute value of hand equals a number? How is that different than this more complicated equation? right there. I got a number on the outside, and I got another number right there, right? Okay, so now, what's the goal of that? Put on itself. I want to get it to look like the other one. So I want to get the absolute value by itself equal to a number, right? Now, one way to do that would be maybe to distribute the two, but then I'm going to have to just undo that later when I solve. So it's not a bad idea. What's my other option? If I want to get just this part, the absolute value bars, by themselves, what's another way I could do that? Okay, good. I could just isolate the absolute value bars algebraically, right? Just like you would if you were solving for a variable. What are the two steps in order to get the pink bubble by itself? First I would subtract 3, and then what else? Divide by 2, right? That's it. Okay, so if we subtract 3 from both sides, look what we get. So those go away. I get 2 times the absolute value, x minus 1 equals 10. Last step, divide by 2. So now we've got the absolute value bars by themselves, and we can just make our trade, and we're simple algebra from there, right? So we get absolute value, x minus 1 equals 10 over 2 is 5. So now we'll make our trade. What two regular non-absolute value equations do we get? Either x minus 1 equals what? 5, or x minus 1 equals negative 5. Just solve them. They're easy, right? I'm going to get two answers. If I add 1, I get either x equals 6, or what do I get on this side? Negative 5 plus 1 is negative 4. So those are my two answers. Make sense? Okay. So once again, our steps are isolate the absolute value bars, and then trade for my two equations and solve them. Okay? That's it. All right. How are we doing here? It's a good place to stop. Go ahead and